Hello everyone, it's Wilson here. Today let's talk about finding the parametrization for the top half of the sphere center at the origin with radius 3. This is the surface that we are looking at here. See that the bottom part is not there. I'm just drawing some dash curves just to show that the bottom part is missing, just the top portion that we want. And so this portion, this surface is given by z equals the square root of 9 minus x squared minus y squared. Okay, and because this is part of a sphere, so we are going to use spherical coordinates to do the parametrization. So first, we are going to pick our two parameters as phi and theta. You can use u and v if you want to. So now we are actually ready to start writing this. And as you know that because the radius is 3, and we are including all the points on the surface. So that means the rho would be 3 in this case. And then we are going to use sine of the angle phi and then cosine theta. Okay. And then for the y, then it would be 3 sine of phi and then sine theta. What about the z? The z would be 3 cosine of phi. Okay, so now we have the parametrization here. And then of course, that's not enough because we still need to set the bounds for the phi and the theta, as you can see here. Okay, so one thing that I should just put down here, this part is rho, but rho in this case would choose 3 so that we have the two parameters, phi and theta. So now, what about the domain for the phi? Well, remember the phi is the angle that's formed with the positive z-axis. So if we start from this point right here and then our whole surface actually goes all the way down to the xy plane. So from the positive z-axis from this point and then go down right here, what happens? We actually will have an angle from 0 to what? From 0 to pi over 2. So you get 0 to pi over 2. To just show that, then I can just show it right here. So start with the phi equals 0 right here, and then it will go down this way all the way until we hit this point, as you can see. So you can see that we get phi equals pi over 2. Okay, so phi goes from 0 to pi over 2. And then what about the theta? The theta is actually just the same angle as the angle defined in the polar coordinates. And so you know that this actually covers the whole xy plane, right? As you can see that we have a point in every quadrant. And so in this case, well, it doesn't cover the whole xy plane, but then as you can see that it will cover all 4 quadrants right here. So we go from 0 to 2 pi, as you can see. So what happened is that for theta, then we start with theta equals 0 right here, and then we just go up to here, pi over 2, and then just keep going. And then all the way come back to here, which is theta equals 2 pi, which is actually the same spot as the theta equals 0. So we get theta going from 0 to 2 pi. So that is the parametrization. And then we are going to see a similar example, but with some details that are different. So now let's look at this example. This example is extremely similar to that one, but there is the one piece that is different is that this portion of the sphere, it lies in the first octant. We only want this portion. So that means it's just this part right here. We don't want anything in the back, and we don't want anything that is in the bottom hemisphere. So we only want this part. Then how do we parametrize this? The parametrization is almost the same actually. So we are just going to just quickly write it down again. Okay, as you can see that it will be 3 and then sine of phi cosine theta. And then for the y, it would be phi and then theta. Then we had 3 sine of phi sine of theta. And then z would still just be the same thing as the previous example. So 3 times cosine of phi. Okay, so all this are really just the same thing. The only thing that is different, okay, would be the domain for the parameters. So for the phi, Okay, for the phi. Actually, for the phi, the domain may be still the same as the previous one because what do? We start from here. This is where? This is phi equals 0. Okay, so we start from this point and then we go down until what? Until we hit the xy plane. So what happens? We are going to get phi equals pi over 2. So see what's going on here. We get from 0 to pi over 2. So the phi is actually the same thing as the previous example. But for the data will actually be different this time because we only want the portion in the first octant. That means we only want the portion in the first quadrant if we just look at the xy plane. Okay, so in the first quadrant, that means we are starting from data equals 0, starting at this point, and then we start going this way, and then we will stop right here, which is what? Which is data equals pi over 2. So as you can see that we start from 0, which is the same thing as before, but this time we don't go all the way to 2 pi because we don't cover all 4 quadrants, we only cover the first quadrant. So we are going to get pi over 2 right here. So this is our parametrization. If you want, you can switch the phi and the data into u and v's. It's really up to you. It doesn't really matter. Okay, so hope you like this video. Thank you for watching. I will see you next time.